as always, by Nick, our online content director, who has been providing the technical knowledge to run the stream and who has been talking to you in the chat already to let you know that we were going to start a little late, but we're good to go now. I'm also joined today by Deborah, our program director, who will be facilitating today's talk and who will be introducing our speaker, who has also joined us, Karen Lopez. But before we get started, I just have a couple items of housekeeping. So first, I want to let everyone know that our CDMP Data Management Fundamentals Exam Prep course, the dates have been pushed back to November, so there's still time to register. You can find more details on our website or send any questions you have to communications@irmac.ca. Then before we get started, I just want to thank again, as always, our sponsors. First, San Francisco Partners, whose support allows us to bring you these streams and helps provide the technology. And our other sponsor, InfoSet, whose support provides a lot of our operational activities and allows us to bring you some of the other stuff that we're hoping to bring you. So without further ado, I'm going to pass it off to Deborah to introduce Karen and our talk today.
Okay, right. So I'm going to share my screen. I'm, of course, Deborah, the program director for IRMAC. And so this month, we're bringing you blockchain for data professionals. And this is our event page on irmac.ca, and I urge you to visit it every once in a while to take a look at our past and future events coming up. First of all, I'd like to introduce Karen. I'm sure you're familiar with her if you've been on our channel before. She's such an expert in so many areas, but particularly she's a VIP with Microsoft. She's with InfoAdvisors and a space enthusiast and a NASA Datanaut. Karen is a senior project manager and architect with extensive background in development processes. She has 20 years of public speaking and keynotes and demonstrations, and she wants attendees to have fun, gain insights, and take away inspiration for working with new technologies and methods. Karen's sessions are always very popular as she gets your fun factor up, and she also gets your brain bubbling with new ideas that perhaps you aren't familiar with. She's known for her slightly irreverent, yes, and practical approach for IT training and speaking. And she wants you to be part of Team Data.
Yay.
Yay. So today she's going to be talking about all the hype around blockchain and why a DBA or other data professional should care about this. In this session, we'll cover the basics of blockchain as it applies to data and data processes. And she'll go through all of the topics in the bullet list below. I think they could be controversial as well as very informative. We'll look at current offerings of blockchain in Azure, SQL DB, SQL Server, and Oracle databases. And finally, she'll help you identify types of business requirements needed. All right, so over to Karen. I'm going to stop my share and over to her.
Thank you. I saw one of my cats go by, so she'll just be joining us for a little bit. By the way, her name is Hansen, and she's named after the next Canadian astronaut scheduled to go somewhere in space sometime in the next couple of years. I'll just say that.
Right.
Let me get my screen shared and share the right one. Okay, it says it's sharing my screen, so that's good. I'm going to go ahead and turn off my camera if I can. Let me find that window again. And it's like I haven't been doing webinars forever. So, okay. It's not really wanting to do that, so I'll just leave that on. Anyway, today's topic is blockchain for the data professional. And what we're really going to focus on today is not the traditions of blockchain or Bitcoin or any of those things, but how it applies to databases, data models, and security and data tampering. So as Deborah said, I've been doing data stuff for 20 plus years. It's really 35 plus years, but I don't like putting that on slides when I talk to much younger people. I do want you to love your data, and I do think blockchain is a way of loving your data. Why this topic? So this topic is because blockchain is a huge buzzword. But the focus of blockchain that a lot of people have lost in all the news stories and everything is that blockchain really is about data and being able to trust that data has not been tampered with. I want you to be able to take away a better understanding of how blockchain applies to the work of someone working in data management, data architecture, data modeling, anything data. And I want you to know that I own a blockchain dress, which is what I'm wearing right now, because I'm sure all the rest of you have worn your favorite blockchain wear. The other thing is, ask questions at any time. It's my understanding that questions go in the YouTube comments and that someone will happily ask your question on your behalf. And I am perfectly fine with an interrupting comment or question or asking for clarification. And I will tell you right off the bat, the way my brain works is sometimes I might say Bitcoin instead of blockchain, and they are totally different things. But it's just, it's a feature of my brain right now. I'm not sure why. Why for you guys? I think it's important as blockchain comes into traditional relational databases that it's important that a data architect understand those features in case it comes up in a meeting or in case the developer says, we're just going to put a blockchain table in there and you'll know what it means. There are some really great business cases for why we need this type of advanced secure computing in our data, and we'll talk about those. And again, if it's in a database, then if all your job is to run data models back and forth, you'll need to know, because eventually anything in a database has to show up in a data model and vice versa. So what I'd like to know, and I won't be able to see the comments, but I'd love if everyone else could, if you could put in the comments, are you a DBA or a data architect, a developer? Are you an infrastructure person, a manager? If you're a manager, we have pictures, or a data scientist. Not what your title is, but what is in the core of your heart, what your mama raised you to be is your type of role, because that would be interesting to find out what sort of data people or even non-data people we have participating today.
We already have a critical question from the audience.
Excellent.
They want to know what images are printed on your blockchain dress.
So actually, I have a snippet from it in the actual slide deck. So you'll see that coming up really soon, so you can see it even closer. But it's
Wonderful.
basically blocks and chains. Thank you for that. The other question I would normally ask people if we were together again is, have you used blockchain either personally or professionally, involved in any development that uses it? And have you ever gotten rich from mining Bitcoin or owning Bitcoin? I just need to know that. So the other is, there's the image from my blockchain dress, really zoomed in. But this is sort of the basics. So a lot of blockchain presentations I've been to, it's all about how blockchain is going to solve all the problems of the world, how we should blockchain, just everything. And that's kind of the, I have a hammer, what needs to be hammered thing. But just a little bit of blockchain background. So the blockchain technique, concepts, and tools was developed by an anonymous person in order to create virtual currency, and that virtual currency was originally called Bitcoin. These coins are only virtual coins, and there's a lot of news going around about various types of coins. And I'll use the term Bitcoin when I'm actually talking about the coins, but that's like a brand name for a type of coin, and there's all kinds of names for coins. But I still tend to use Bitcoin to refer to all cryptocurrencies. This originally got lots of news because the reason the person wanted to invent these virtual coins is in order so that people could do business transactions without someone tracking them. That was one. So it was used a lot for illegal means, nefarious leads, dark means, but now it's not just for that. There's been so much buzz about who's taking blockchain or cryptocurrency. Are you going to be able to buy a Tesla with your cryptocurrency? Blah, blah, blah. There's lots of words associated with this in terms and buzzwords. There's lots of hate for it. So I'm presenting a version of this at a conference I'm attending next week, and I have a co-presenter, and he really hates the concept of blockchain, doesn't understand why I'm insisting I'm talking about it. Well, the reason I'm talking about it in this session is the workshop is advanced security and privacy features for data people. And so I'm going to talk about this, but there's also lots of good uses. So the basic fundamentals of blockchain is that every transaction, and by transaction here, I mean data transaction, not retail transaction or banking transaction. Every data transaction gets a timestamp, and the way the technology works is the data is immutable, meaning it cannot be changed. Now, we've had this concept in databases, and where we did that in the past is we didn't give people permission to change it. We have rights and authentications. We have change data tracking in databases. We have things that are marked as read-only. We have all these features, but people still figured out how to change things, especially insiders. So that when I say that blockchain leads to tamper-proofing, I mostly mean either insiders or people who get access to the inside of your systems. The other feature of blockchain, which I have another slide coming up, is that the chain itself, these transactions and these security features are distributed across multiply owned nodes, not just multiple nodes, but think of it like if you think of the way nodes work in distributed data systems, nearly all the time, if you set up a massively parallel data warehouse and it's across 60 nodes, you still own and manage all those nodes. Sure, they might be in the cloud, but that's a shared management. In blockchain, people who own servers that they secure carry copies of the blockchain along with other servers. So in order to tamper with the data, not only would you have to get the timestamps in sync, you'd have to be able to attack all of these multiply owned and secured servers, update them at exactly the same time, and also not break the chain. And we're going to talk about how all of this comes together to make it virtually impossible to change the data. But this is the feature of blockchain transactions. You can't change it. Every transaction is linked to another transaction due to the change. And that transaction, we'll see how the hashes, the crypto part of this, keeps the data. If you change and tamper with the data, the chains break, and then everyone knows the data has been tampered with. The other thing is I saw that in true blockchain, all the data is held in multiple places in this multiply distributed nodes. And the blockchain process says, hey, nodes, do you agree that this is the transaction? And once more than half the nodes agree that's the transaction, you can assume that the transaction is valid, that the data has not been tampered with. But you can go ask all the nodes to come back and respond. Now, the other thing about blockchain in data is that it's also referred to as ledgers, and we're going to see that in some of the database names.
Karen, isn't that a bit of a low bar, 51%?
Well, so I agree, like that sounds really low, but the deal is you still ask all the nodes what the chain is, but we're potentially talking about hundreds of nodes that are owned by different people. So that's called verification of the chain. Think about if you're doing this in your database now, you're asking your database one node and one node only, is this transaction valid, right?
And that would be 100%.
And that would be 100%. Exactly. Exactly. But in reality, so the other weird thing about public blockchains like Bitcoin and everything is that anyone can go look at the data, the transactions. That's also something you probably wouldn't do if your data transaction was paying an employee with the employee name and ID and all that other stuff, right? So for these, I'm talking about the principles of blockchain were for managing cryptocurrency, right? And so what it's saying is at 51%, we return validated. It doesn't mean that 49% can say they disagree. It's just once you get to the tipping point of more than half, it can be verified.
Okay.
But
Thank
great
you.
question there. Yeah.
I think I actually recall an episode of a show called Silicon Valley where
Yeah.
one of the competitors was trying to do the 51% attack where they were
Yeah.
activating hordes of virtual phones to try and all impersonate a user to become 51% of the overall user base and therefore gain control of it.
That's right. And we're going to talk about that in a second. So the nodes are distributed, multiply owned. They're based on peer-to-peer architectures. There's the other weird thing about Bitcoin type blockchains is that there's no centralized owner or manager. Like people can basically own these nodes and make them available, including you on your desktop. You can mine Bitcoin, which is you get paid in Bitcoin for providing your compute to do the hashes, because hashes are compute intensive. And that would be great if you could spend back time about 10 years, because right now, in order to mine Bitcoin, you have to spend more on energy than you would earn in Bitcoin, because mining Bitcoin pays these tiny little slivers of Bitcoin. So early on, the most popular way to actually make money mining Bitcoin was to use a regular computer, not a highly specialized, efficient one for mining, and then plug it into someone else's power and network, like your college campus, like a library, like a hotel room, like a Starbucks. The only way to make money mining Bitcoin right now is if your energy and compute is free, which is one of the reasons why some hackers hack into systems, is not to mess with your data, not to do anything bad to you, but to just steal your power and compute so that they can set up something that's mining Bitcoin. And then
so as this all becomes very legitimate, do you see energy companies actually getting involved in mining?
There are some non-traditional, I'll call them computing services companies that are thinking about doing that. And there are people who are truly investing in making that value model either through massive solar arrays or self-generated. Like I live on the Rouge. I've seen these videos because I live on a ravine where you can make your own hydro, meaning actual hydro, by using gravity of water going down the hill. Like I've had all these things in the back of my mind about how I could just generate free money doing that too. But yeah, if we're producing excess energy before we throw it out into the wind, maybe we should produce some Bitcoin on the way out. Anyway, and it's consensus based, which is that 51% thing. So again, this is a highly generalized view of blockchain in general. You have this transaction. That's the first block on the left there. It's a block. It's not block number one. It's got data in it. I then hash that actual data. So if this said Karen Lopez, I would create a crypto hash of that data and call it number one. And then the next block of data, which is now block number two, not only would I create a hash of that data and call it number two, I'd also put the hash of Karen Lopez, chaining it back to that first block. So what this reminds me, if you're as experienced as I am, is kind of like a network database, or you could make a case for relational using GUIDs or something. So the blocks are the data, the transactions in the blue here, and the chains are the hashes of the actual data tying them from one block to the next block to the next block in sequence.
Right, I'm interrupting you again.
Yeah,
So
sure.
what is the data on the transaction? If I was sending you money, it would be my name, my bank account to your name and your bank account, would it not? And therefore have personal information in it.
Yes, if it were a banking thing, but you have to remember, so this concept originated in cryptocurrency, which is intentionally designed to hide who owns the bank account. So in cryptocurrency, you have what's called a wallet. That's kind of like your account ID, but no one can tie the wallet back to you except you, because it's a physical thing. So I remember Big Bang Theory had this concept of Sheldon had stored early Bitcoin on a thumb drive and then, or a CD or something, and they couldn't find it. And it would be worth millions and millions of dollars if they found it. But he physically had to have that wallet in order to cash in the Bitcoin.
Right.
So
I think that's actually happened in the real.
it has.
Where,
It
yes,
has.
where CEOs worth millions and millions have died suddenly, and no one could get into their wallets.
Well, and that one particular one was the owner and designer of a particular coin. So he disappeared. He didn't die. He may be dead, but everyone lost all their coin because they couldn't get to their coin anymore. So this is the other problem with decentrally managed, highly anonymous stuff. So the people who are investing in Bitcoin have extra risks. There was also one case of a small cryptocurrency where the belief is the guy just collected it all and disappeared into the world, and converted it to actual value things and just stole everyone. So it's high trust with no way to trust people. So, but in crypto coin world, this data would have had my wallet ID, the amount and the direction of the transaction, and it's all publicly viewable. So right now, people go in and look at these public blockchain things, not all blockchains are public, and go and look and say someone moved $10 million of Bitcoin in or out, and they try to figure out who it might have been, or $1 billion, because not very many people own that much of that coin. So to me, it's part espionage too.
An interesting story I read recently about the anonymousness of wallets and things like that was people watching more recently the NFTs exchanging and being able to see frequently that the NFT would get traded from wallet A to wallet B, from wallet B to wallet C, then back to wallet A. And a lot of people were speculating that people are trading it back and forth to increase on paper the value of what it looks like. And since it's all anonymous, it could just be even the same person. Just giving money to themselves, but there's no way to tell.
That's right. And the other interesting, so the little side thing here. So a lot of people right now are using cryptocurrency as an investment strategy, right? They're just trying to get in early or get in low, like buy low, sell high. There's a story, there's a wallet. So I'm just going to say a guy because we don't know who it is. There's a wallet right now in one cryptocurrency that's worth like $58 billion on paper. But the sad thing is, it's just like the position that, say, Elon Musk is in right now. If that person tried to cash in even $10 billion of that, the value would just go way down. And so he couldn't. And he might have a hard time finding someone willing to risk $10 billion because he didn't risk $10 billion. He probably risked 8,000, I think I read, to get to 58 billion. So it's all kind of weird financial systems that may or may not actually work. Anyway, so what does this have to do with data? We're getting there, I promise you. So basically the process is you add data or a transaction to the block. That send transaction that you've added to the block sends all that information to the nodes. At any time, someone could say, hey, can you validate for me that transaction? If it's validated, then the adding to the blockchain is complete. And you can also validate at any time, like 10 years after it was added, because the validation is basically, we'll see, is asking a few questions to the whole system. And if they all come back good, it gets verified or validated. So let's talk about the trust. In order to go in and tamper with the data, not only would you have to be able to tamper with the data, do it in a way, replace all those hashes all the way through, you'd have to do it on more than 51% of the nodes without anyone knowing, and they're managed and secured by different people, and do all this at the same time. So maybe someone's going to be able to do that at some point, but right now that there's physics behind this change that would be difficult to pull off, with one exception. So early on, lots of people ran these nodes, and now there's been, just like in any other technology, kind of a consolidation of people willing to manage nodes. And we're getting close to the point where for the large public blockchains, there are fewer and fewer people that have ownership of all the nodes, because people are joining blockchain Bitcoin mining pools in order to share some of the mining activities, kind of like buying pooled insurance. They're buying pooled Bitcoin values. And as that ownership consolidates smaller and smaller, the easier it might be to do that 51% hacking. So as I said, everyone in public blockchain sees the chain, the asset, can follow it, can start tracking it. And so these are truly designed for anonymous transactions, not tied to a person. Now, here's the biggest pushback on blockchain, is that blockchain only verifies that the data that's in the system has not been tampered with. So of course, it cannot verify that the data is actually accurate. So you see all these blog posts and videos that someone inserted into a blockchain that, hi, I'm Minnie Mouse, I'm a billionaire, blah, 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 and the blockchain took it happily. And that is because it's not blockchain or blockchain theory's role to validate the accuracy of the data. It just validates the data in the system hasn't been abnormally changed. So I'm a bad person. I tell the blockchain that I put $4,000 in this transaction, and it's $4,000. But what I actually put in was 1 cent, and the blockchain will validate that I put in $4,000 because that's what I told it, when in reality, I only sent this pigtailed woman with 1 cent. So a lot of the hate on blockchain is because people misunderstand what it's validating. The other thing that's interesting in most of the enterprise and commercial uses of blockchain is that these could be set to be event triggers or event-driven systems. So for instance, in the commercial world, blockchain is being used a lot by shipping, delivery, and logistics companies. And that is because they've had to deal with a history of people in the middle of that shipping chain, not blockchain, but shipping system, fussing with the data. Oh yeah, I only got 4 cases of this. Oh yes, the air conditioning on my truck was consistently below 40 degrees, even though I turned it off and parked it in a parking lot in Vegas for 3 days while I gambled. So this is being used commercially in places where not only do we not want tampering with the data, but we want certain things to kick off as soon as the transaction's validated. So think about any event-driven system you've done. Your package was delivered, that gets put in the blockchain, boom, now another event could kick off, like billing you for it or invoicing you for it or something like that. So let's talk about traditionally how we think about data. Most of the IT enterprise systems I worked on were ledger driven, and by that, I have my own books at my company. That's my ledger. That's that sense of the term ledger. I manage it. And the way I guarantee to Revenue Canada and the IRS, and if I had business partners, that that data hadn't been tampered with or mismanaged, is I would procure an audit to prove that it hadn't been tampered with, not the auditing parts about was that expense an actual legal expense, but the tax expense form that I actually submitted has not been changed to add another digit in front of that $10 ride to make it a $110 ride. It requires constant reconciliation, which I do with my books. It's not always secure, but it may be encrypted. In blockchain, because we have all these other things, we don't use auditing as much to see if the data has been tampered with as we just use the features of the chain. So those were the theories of blockchain. Do I have any more questions about the theories of it? I'll take that as a good to go. So let's talk about my favorite thing, which is the actual blockchain and databases. So as far as I'm aware, the first sort of big traditional relational database system that came out with blockchain features was Oracle. This came out like in the last year or two. I don't know, my years are off recently for some weird reason. So they've introduced a feature called a blockchain table. And you can see the creation syntax, the simplest form of the creation syntax right there at the bottom of this slide. Create blockchain table and call it trade ledger. That's the SQL for it, the SQL for it. So it focuses, unlike this big blockchain thing, because of course your Oracle database isn't sending its data to multiply owned separate nodes. Blockchain features in databases are focusing on what can I use internally to make the data less tamperable, if that's a word. And so for Oracle, their blockchain tables are insert or append only, it's called. So insert only. You would write this data transaction to a table. It's going to do the hashing and the encryption and the chaining right inside that table. So Oracle databases, these blockchain tables aren't any more distributed than your normal database might be distributed for availability or scalability or something like that. Just like any other table, it's not visible to others, so no one can go in and check to see, oh, someone in my invoicing database all of a sudden sent an invoice for $5 billion. No, it can't be done. And it's still under centralized management, just like all databases in your company. So some of the features of it are encrypted signatures, so that helps cut against someone that's regular database public key infrastructure type protection of data. It's encrypted, just like we can encrypt other things in a database. Trust but verify. So yes, the hashes are in the database, but also at the same time that this transaction is recorded in the blockchain table, the hashes and the data are stored separately from the database, usually in some secure computing storage. And then you can run your verify script that says, please verify these transactions in this table, and it will go into your table, look at the data there and the hashes, and verify, ask the I'll call it offsite, but I just mean outside the table, storage of the transactions and say, yep, it all matches, it's all good. No one has messed with the database table unless they also had access to this outside the database storage. Because these smaller internal blockchain tables don't have multiple nodes that have to be queried, we're not doing the full-blown consensus of multiple nodes. So this is a trade-off between not having full-blown blockchain and just having blockchain tables in your database. So that verification of nodes can sometimes take time. So we're talking about, you know, minutes, not days, but we're also not talking about a typical database performance requirement of milliseconds. So the way it works in Oracle, a blockchain table, that block is a row in the table. It has regular columns that look like regular table columns, and then there are some additional system managed columns. But the little badges there on the blocks mean that you've protected it the way you protect other tables in your database. It still has all the hashes linking everything together, which is different than the primary key, foreign key constraints that you would normally think of linking things together. And then it has this addition of an audit log of the hashes and the signature stored separately. So if any of the data were to change, it wouldn't verify. And this is just a graphic I took from the documentation where where you have these rows, a bunch of, they're called hidden columns. You can still query them, but you don't want someone running a select star or a self-service BI report to have to get all these hashes returned and have to screen them out. And it basically just chains the rows together in a table with the hashes. So some of the settings that you can put in Oracle blockchain are, hey, I created this table, no one can drop it. I created this table, no one can drop it until it's been untouched for 90 days. I can't delete a row. I can't delete a row until X number of days after it's been inserted. And remember, these are insert only tables. And then there's also this function that I can say, please go and verify everything in this table against the audit log. So creating a table might look like this. I've created a BC tab _ part blockchain table. It has all this normal stuff. I've said for this one, don't allow the table to be dropped until it's been idle for 16 days. Don't delete a row until 25 days after insert. Here's how I want you to hash those hash values. It's got a partition just like any other table. And this partition thing really has nothing to do with blockchain. It's just a typical partition table by dates. So some restrictions that Oracle has put on their blockchain table. You can't update anything. You can't merge rows. You can't do anything to the structure of the table. You can't truncate. So truncate means delete all the rows in the table. You can't drop a partition. There's triggers you can't do. There's all these other features that you can't do against it. Most of it having to do with the fact that in Oracle's world, a blockchain table is locked down tight. And if you need to update something, you don't update the row, you put in an offsetting row. And you can go read about all those. I don't work with Oracle a lot, so I don't know what all these things are. But if you're an Oracle person and you want to go read, you can go find out about blockchain tables. Any questions about the Oracle blockchain tables? Okay, so like any other good vendor, Microsoft SQL Server has gone off and built in blockchain-like concepts into Azure SQL DB. Azure SQL DB is the SQL Server as a service version of SQL Server in Azure. My guess is, and I have no inside knowledge of this, is that because Microsoft has this cloud-first deployment, they have implemented this in Azure SQL DB. And eventually, after they've gotten it to the point they want to get it, they will probably be introducing it into the on-premises version of SQL Server. That's generally how most features go. So the difference between what I just talked to you about Oracle and Azure is that Microsoft has decided to have not just an insert-only version of a blockchain table, but one that acts and looks like it has update ability, so that you could go and update a transaction. Under the covers, it's still doing all the offset stuff, so it's not actually updating the value in the row, but it allows people to interact with that data in a way, the same way they would interact with another type of table. The other thing that Microsoft has implemented is they allow you to specify that the whole database is a ledger table database. So if you create the database as a ledger database, they will make every table in it automatically a ledger table and implement all these features to it. What else is different here? Oh, and they also allow you, it has the same audit file feature as Oracle, but you can also choose to implement it in some of their confidential computing-based storage, which is a specific term that's kind of outside. It is much more secure than a regular virtual machine, either a regular virtual machine or a Azure SQL DB running in Azure. So it works pretty much the same, other than the fact that it's added a layer on top to make it look like it's updatable. So I talked about ledger tables. They also have the concept of a database digest. And this is sort of a thing that you can query and verify that's represent a state of all the ledger tables in a database at the time the block was generated. So it's just another feature that's added in there. When you create a ledger table, you say whether it's append only or updatable. It does have this immutable storage, which means it's physically unable to update the storage to store the auditing things. And it also has the ledger verification feature. So if you wanted to create an insert only, append only Azure SQL DB ledger table, you create the table, you add in your regular columns, and you just say with ledger on, and you can say append only on. So everything else is pretty much the same if you've ever created a table in SQL Server. If you wanted updatable, it's the same thing. You can create a table and you say system versioning on, ledger on. So system versioning being the keyword for updatable. So here's what it might look like if you created an updated ledger table. So you can see in the results in this first query results that Nick Jones has a balance of $100. Those ledger start transaction day, ledger in transaction ID, sequence number, in sequence number. Those are all the special system columns that get generated for a ledger table. And if you updated Nick's account balance to 50, it would go do this. Now you can see in the top query results, rows 2, 3, and 4 have the same ledger start transaction ID. This isn't the hash at all. This is just recording in the ledger that those 3 rows were created in the same query, the same database transactions. So we're talking about different kinds of transactions here. So there are database transactions where you say, here are all the steps I want you to do to my database and wrap them in a transaction so I can roll the whole thing back if I need to. These rows 2, 3, and 4 were all created at the same time, so they got the same start ID. So it looks like under the cover that Nick's balance changed. Let me sure if I got this right. Oh yeah, it went from 100 to 50. Underneath in the real table, it actually shows, as you can see in point 3, the fact that I inserted a row. Oh yeah, it went from 50 to 100. Sorry, I said that backwards. We soft deleted the $50 row and inserted a $100 row. So it's just like double entry accounting. You don't actually delete, you don't actually update, you have an offsetting transaction or a new transaction. And then there's a way in Azure SQL DB to go ask the digest to go and ask SQL Server to go verify that the ledger table data and transactions matches the one in the secure storage version. And you can see at the bottom of this slide that ledger verification succeeded. And this verification is a normal part of doing blockchain. So this isn't like, I do this at the end of the year as part of an audit. No, you would normally do this on as you do transactions. So like the restrictions in Oracle, there are restrictions in Azure SQL DB. You can, if you want, update and merge rows because you have this layer that makes it look like you're doing that. You can't go into a database and turn off the fact that it's a ledger database. You can't rename tables. You can't alter a table, but you can do some minor changes to the table. So this is also kind of an interesting thing because the exact things you can do is a long list and you have to be able to read T-SQL or know the verbs and nouns of T-SQL to do it. But they let you do things that can't destroy the data, which I think is a nice compromise. Like you could take a column that was varchar 50 and make it varchar 75. That sort of change to that table isn't going to harm any of the underlying data, and it allows you some flexibility for making adjustments. You can't make a date column into a character column. You can't, delete a column. You can't do some of those things, but you can make sort of the normal, some very indestructive tweaks to your table, but Oracle doesn't allow you anything. So in the Oracle world, if you want to change your table, you will have to create a new table, load in all your data again, and then put that table into production. There are all these features that you can't use, a lot of them because they're very physical, because either they haven't supported this yet or they're never going to support it. So in-memory tables aren't allowed to be turned into ledger tables. But you can't, these are restrictions. So you can't truncate an append only table or an updatable table's history. You can convert a ledger table to a regular table, but you can't go the other way. So once you've created a table, you can't ledgerize it. A transaction, and this means a database transaction here, not a blockchain transaction, can include up to 200 tables. I don't know about you, I don't have a lot of transactions that hit 50 tables, let alone 200. And there are other limitations that are very similar if you're familiar with SQL DB's temporal tables. Any questions about the SQL Server ones? I know that was exciting. But why would you do this? Why would you put all this blockchain overhead right inside your database instead of using a normal blockchain process, which both vendors also provide? So Oracle has blockchain services that are totally outside of SQL Server, and Microsoft has blockchain services totally outside of SQL Server. Well, one of the reasons to do it is to just make data right inside your database more trustworthy against tampering. So some of the security features in SQL Server and Oracle and DB2 and all of them have been put in to keep someone from tampering with the data. But adopting the blockchain approach just adds that extra layer of tamper proofing. And it especially works well with DBA or sysadmin tampering, which is the hardest thing to secure against, because a DBA with owner rights to a table can do a lot of things, like change the table and change all the change data logs and get rid of all the evidence behind them. That might be auditable, but it can still be done. And one of the interesting things here is I let PowerPoint choose these icons for me. And for some reason, every time I use DBA, it chooses the skeleton, which I don't understand, but I like keeping it in there. But the main reason to do this is you want the extra tamper proofing, but you don't want to roll out a whole bunch of either private or public blockchain infrastructure. It requires a lot of infrastructure. So it's kind of a happy medium between full-blown blockchain infrastructure and the traditional older school anti-tampering that we might do in a database. So the benefits of blockchain inside a database: shorter processing time. Like the full-blown blockchain thing, you got to query all those nodes. You have to wait for 51% of them to be written. That takes a long time. It's also much cheaper because whatever you're already paying for your database is what you'll pay to implement blockchain or ledger tables. There are fewer certain risks, and the breadth of the risks are much smaller. And also you get to say, I work with blockchain every day. So some of the fluff about blockchain. Some people associate blockchain only with doing bad things. And that was true early on, but plenty of the systems you work with, on things you order online, on the food you buy in the grocery store, the counterintelligence threats, all of these things are utilizing blockchain and blockchain concepts. So yes, there's a lot of fluff, and yes, it's still being used for hidden or illegal acts, but that's not the whole story. I once had a delegate at a conference sit next to me and told me that all banks and financial systems would be out of business within a year because blockchain is free. So any companies that charge small fees or big fees for buying and selling and trading things would just be put right out of business. Well, until you agree to take your salary in Bitcoin, that probably isn't going to happen anytime soon. So while these organizations I have listed there are curious about crypto coin things, that doesn't mean they're switching over to it tomorrow. But all of these companies, I can guarantee you, are either investigating blockchain, not Bitcoin, blockchain for tamper proofing, just the same way any other business is.
And I believe, if what I've read is correct, that for the actual coins on blockchain, Bitcoin, Ethereum, those ones, they have new systems of exchanges that have been set up to facilitate exchanging of coins, which charge small little fees to do so.
Yeah, there's that. And then also, so you've probably heard this, but there was recently a company that set up to do currency exchange of Bitcoin, and it went out of business. Did I hear that? I think that was a recent news story. So someone said,
But at the same time, there's countries which are now legitimizing Bitcoin as real currency. So, you know, your story about someone having billions of dollars in Bitcoin, they could legitimately go out and buy a super yacht now and not have any problem doing that.
Exactly.
So there's definitely a movement here to legitimize it as a currency.
Absolutely.
I also, and going on to the quote unquote illegal activities that can be committed using, mostly using the different types of coins, I believe. I think the US government passed a law or something the other day that was about having the IRS look into and making any exchange you make with Bitcoin or NFTs or things like that over $10,000 be a taxable thing by the IRS, that you have to declare both the person doing it and the person receiving. It should cut down on a lot of illegal activities, I imagine. It will a little bit. The anonymity, I imagine, is a huge department.
So that's going to be the issue. So I put this in the same bucket with, I think in Canada too, but definitely in the US. If you bought something from a state and it got delivered to you in your province or state and you weren't charged sales tax on it because they didn't have a presence where you are, and therefore they don't have to charge it, you're legally supposed to report the fact that you weren't charged sales tax to the US federal government on your taxes and pay it to them or pay it to the state. Now, I don't know people who do this, but that is how it's supposed to work. But people don't do that. And the $10,000 thing, I mean, that's like the $10,000 at the border. It's not illegal to take $10,000 across the border. You're just obligated to report it so that they can check to see if you're doing something illegal with it. So I think it fits all into that thing. But you're right, as crypto coin becomes a legitimate currency, then it'll have to fit in our normal legitimate currency processes. So some blockchain in real life, I've mentioned a lot of these: supply chain, inventory, transportation, healthcare, utilities, financial, definitely being done in all of those areas.
Oh, and a question from the chat. What's the difference between this kind of blockchain table and a hyperledger blockchain in general?
So I'm not familiar with that term, but if that is a product offering from somebody, it just means today I'm talking about blockchain tables inside traditional databases. There are also ledger databases and blockchain database systems that you can go deploy as well. I forgot to mention that. I know Amazon has some. I don't think Microsoft has it, but I could be wrong because I don't work in a whole lot of other databases. It's just today I focused on the things that are probably going to become more real for us traditional data people because they're being deployed in the tools we already use as opposed to a new tool. But if you want to clarify for me what a hyperledger table is, I'd be happy to do that. I know that's a non-answer, but it's the best I could get.
Makes sense to me, and they've heard it to clarify if they want, so hopefully write in chat when they do.
Yeah. Some other, like just some stats I pulled, and these are fairly old, meaning a couple of years, that a large global retailer's Canadian operation has more than 500,000 loads of inventory that are going into a blockchain, 853 million cases of merchandise. And the reason they did it was significant cost savings and faster payments due to all those triggers firing off things, right? So in the past, retailers wouldn't pay an invoice until a long time after, because they had to verify and count things. And yes, you still have to count things, but just because some delivery person said, I delivered 300 of these things, now you can switch together the length of those processes, because you know you don't have to verify that the data, that the forms haven't been tampered with, because the forms were put into a blockchain. Now all you have to do is reconcile the count to the claim. Some other stats from 2019, we're spending billions of dollars on blockchain. It's been increasing, and I should go update this, what the prediction is for 2022. So my other interesting stat is that Bitcoin miners are paid to provide consensus on transactions, as well as to generate those hashes. In 2017, miners used more energy than all of New Zealand. In 2010, an early Bitcoin user bought 2 pizzas for 10,000 Bitcoin. And in August of this year, 10,000 Bitcoin was worth more than $66 million. So just think, if you were an early Bitcoin user and you realize now, and you had no way of knowing, that you spent $66 million on a pizza, just so you know. What does this mean to you if you're a data modeler, data architect, data lake person, data warehouse person? These features are in the relational database systems right now, and you need to be checking if all the tools, whether it's a data modeling tool, a data governance tool, a data catalog tool, are going to be able to sufficiently support these. I want to go do this. I just haven't had time to go check, ER Studio or Power Designer, and go see if they're supporting these things. You'll want to understand when to use blockchain table versus full-blown blockchain systems if the requirement comes up. And you'll want to understand the nuances of the database systems or the data lakes that you support on where those constraints, restrictions, and gaps are. I recently checked on this event. It got a new brand name, and I forgot to update the slide, and now I can't remember it, but there are plenty of blockchain user groups that are focused on the enterprise IT stuff that we would probably talk about. Of course, there are groups about Bitcoin and how blockchain is going to change the world and all that other stuff, but I prefer to attend sessions that are about the stuff that I need to know about blockchain. So the reason I gave this is everything's all about the data, and that's all we have to worry about. And that's all I had for right now. I'd be happy to take other questions or discussions about this.
Karen, it seems to me that there's still a lack of trust of whether the thing that you were putting on the chain actually happened in the real world and is sustainable. Yeah. So I've seen reports about NFTs, the non-fungible tokens on art sales, which are going for millions, where you might own a digital piece of art and then they move that digital piece of art somewhere else or delete it, and your money's gone and your piece of art is gone.
Yeah. So I don't understand. I mean, I understand the concepts between NFT, but I don't understand it.
Right, NFT, I've heard described as something that if you do end up describing it to someone, they almost always get confused because it doesn't sound like it makes a lot of sense.
Yeah.
Because you aren't actually buying the art when you get an NFT. You're kind of getting like a mailing address to this is where you can find the thing. And this piece of paper says that technically you own this piece of paper that says that's where that thing is. But it doesn't conform ownership of it.
Yeah.
And so it's kind of a really weird place. And
like if someone told you you'd think it was 100% a scam, like once, and there's some great memes out there that explain it and then say, you thought I was like weird. But like, I know, to draw in the Canadian side, I know Drake is selling some MFTs. Is it for $1 billion? I think I heard, or is it 8 billion? Like,
I would heavily suggest that no one get into NFTs until this IRS thing has passed in the US.
well,
Because when people start getting taxed on the supposed values of the NFTs,
Yeah.
I think that's when we'll actually see what their real value is. Because right now, there might be, I've read online some people warning that with this law looming, people might be trying to move as much as they can, and some people might be left holding the bag of something that the day before the law happened was worth a lot of money. And the day after the law passed is not worth much at all.
Yeah. And it's just like, it'd take an hour to explain it, I think, you know, but the whole thing is, it's also exclusive ownership, I think, is the key thing, right? So someone sells you a thing that's not a real thing, it's a digital or virtual thing. And it's kind of like you're owning the concept of owning it. You don't actually own it. And of course, people can make copies of that image by screen capping it, or it's not necessarily an image either. It's just not a real thing, but it's real because you can own it. It's just weird. And so either it's the best scam ever made up, or it's going to totally change how we think about value. One of those two things.
Right. Right.
I think I've heard the term golden brick tossed around.
Yeah.
It's a classic age-old scam.
Yeah.
Which might be true, it might not. I'm not going to
exactly.
make it defend your call.
Yeah. But on the upside, I think you said in so many words that, for instance, the supply chain that you mentioned, that you can get rid of, quote, you know, product loss or, you know, stealing. With the blockchain, maybe, but maybe not, because it suffers from the same, what am I doing in the real versus what is a trusted transaction.
Right. So for instance, what it gets rid of is part of the process in the middle, and that is the recording of the data transaction. So it'd be really hard to go in after a delivery has been made and change the data to say you only got 50 when you actually got 100. That's all it does. But that's also the way most of our real life systems work. Like I work in warehouses, not data warehouses, but retail warehouses, like actual distribution centers. And yes, we still have to count and reconcile and let the vendor know that 3 of the cases were spoiled in shipping, and that the produce arrived unacceptable for human consumption. Like we still have to do all that stuff. But in the real world, we typically, because of system pressures and time pressures, like we take the transaction that says on this trailer, 5,000 items arrived, that gets reported as part of the shipping transaction as a receiving document. That gets matched up to a purchase order, and all 2 of those things get matched up to an invoice, and it gets paid. And after the fact, we do all the return to manufacturer, return to vendor, reporting losses, like those things.
But still, if you shipped 5,000 but only received 4,050. I mean, that would also go on the chain.
It would.
And then, but it would trigger an investigation, which it would without blockchain anyway.
It would. So that's the whole thing. I mean, you're hitting it right in the center of the target. What blockchain does is takes out the lags and the lack of trust. I've worked in retailers where someone paid off someone in invoice matching to go in and fudge with the data, right? Or to overwrite the reported losses or shrinkage or whatever we're calling it. So this is, in a sense, to try to protect, it literally only protects the data transactions, which is still a vulnerability in our systems. especially when it comes to healthcare and financials and logistics and all of those things.
So in other words, it protects against, your own employees, insider.
Or a
problems.
hacker coming in, right?
Right.
The same
right.
thing, but someone who's inside and can get access to the data. So you're right, it's not protecting all the people putting bad data in.
Now, at the same time, if you're a small to medium-sized business, and there's always been the struggle in IT for separation of duty, the developer can't be the same person as puts in production, that kind of thing.
Yeah.
It protects the one individual from, in a small company from, tampering if they wear several hats.
Right. And as well as in a giant company, someone who you just need to have someone who has access to the production data, right?
Right.
So,
Right.
and often those people who have enough admin rights can also go in and change the logs or the history table or whatever, right?
That's what I was going to say is the key thing here is that it also keeps a track of all of the history of the editing, the inserting and deleting, and makes that immutable, even by someone who should have access to everything else in a regular system.
Exactly.
And that's the key thing.
Right. And if you make the mistake of granting that person both access to the database and to those secured enclave logs, you've basically kept your door wide open. So the theory is the database rights to that secured storage, and anyone who has access to the database has zero access to the secured storage. And the secured storage hopefully is using hardware that physically prevents the change of that data, which is a possible thing using confidential computing.
Right. So this sounds like, to draw the dot between something historical, like a data warehouse type 2 table on security steroids.
Yeah.
Because you're keeping all the history.
Yeah.
But now you're making it immutable.
You're making it immutable, and you're also, so the other key thing is those hashes, the chain between the blocks. If you mess with the data, you've broken all the chains. It would be like if you, like the laser beams in an art gallery. If you mess with it, you're going to set off, like the whole system is going to go wonky because your chains are all broken, right?
It strikes me as one of those issues that computer science always has, which is, if the idea, the classic example of internet security is that if someone wants to break your internet security, given enough time, they will find a way.
Yes.
And this is the same with like logging the changes to your database.
Yeah.
It's just another way of trying to get down to a way to actually get to the point where you're like, no, we will know exactly what's happening. No one can mess with it.
Yeah. And I'm sure I'll be sitting here 5 years from now talking about how hilarious it was. We thought that blockchain tables were enough to protect our data. I mean, they'll just be something else. But right now, so the other thing is that, people are going to run out, developers are going to want to run out and blockchain all the things, like make every table a blockchain table. And we as data architects, if I can assume we all are, need to kind of sit back and do the cost, benefit, and risk, because there is a slightly additional cost to this, like that you can't modify the table much, like the fact that updates are really inserts and soft deletes, because those are then going to make your tables big. Like there's a price to pay, a trade-off, really, not bad or good, but a trade-off to a blockchain table. So in theory, we should be pushing back as a good data architect, data modeler, and saying, hey, yeah, it makes sense for us to do it on this, but maybe it doesn't make sense to do it on this list of countries table. Although you might work in a business where you can't have anyone messing with the list of countries table. So we need to be aware of this. Yeah.
A long time ago, I recall when blockchain was first becoming a thing, I recall seeing a flow chart online where it was like, do you need X? If no, you don't need blockchain. If do you need Y? And it just kept going through each thing. And only if you said yes to every single one of the 10 items, then blockchain might be something you need.
Exactly. And there are a lot of people who think like the traditional public blockchains are free, right? That's what that dude told me who sat next to me at a conference lunch. It's not free. It's just free to the end user. And it's free to the end user because people are doing data mining and getting a cut of cryptocurrency when they provide the compute and the energy. But again, that value statement only works right now if you're able to get free energy and free compute, or nearly free on all of those. And then someone's also done a study. So not only do you have to pay for the energy to run these GPUs, which typically are optimized to do mining, or even special computing devices to do it, is just the extra heat in your house or your office you have to offset as well, because you've got a mining rig set up. So the costs just keep going up no matter what you do. So we as data architects need to understand these concepts, find out if our tools will work with these new database features. Right now, I'm only aware of blockchain tables in traditional relational databases for Oracle and SQL, and it's only the cloud-based version, Azure version of SQL. I expect it to hit the on-prem version of SQL Server. Don't know if it will. And I know right now DB2 doesn't support it, but we should be watching out, because the way the market works is once Oracle and Microsoft implement a feature, the other database vendors will eventually try to add that as well.
And wow, I personally think that I could probably talk about this in the greater structure for like another 45 minutes.
I
Me
know.
too, me too.
Unfortunately, we're past time, but
I know.
dang, it was fascinating.
I'm fascinated because it's in databases. I wouldn't be doing this talk if it was just regular blockchain.
But I just want to say thank you so much for doing this talk today, Karen.
Thank
It
you.
was super interesting and enlightening, and seeing different ways that it actually has real applications for businesses.
Yeah.
I was actually surprised by a couple of those.
Oh yeah, a lot of government use that I didn't include here, just because high secure computing needs high tamper proofing.
Right,
Absolutely.
right.
And you
Well,
showed
thanks
ways
very
to
much
contact them.
today. Yeah, thanks very much today. This has been fascinating. Hear from what Nick said. And with that, I think we'll wrap up. This has been one of our longer sessions. It's been so fascinating. Thank you so much for your time, Karen.
Thank you.
We really appreciate it.
One more thing to our viewers. We are currently doing a CDMP course.
Yes, we are.
I've linked it, a prep course for it, and I've linked it in the chat. Be sure to take a look at if you want to get it. I believe we have a 100% pass rate from the previous people who all took it, I believe.
It's happening in a couple of weeks. So
happening in a couple of weeks.
Yeah. Thanks, guys.
Thanks so much. Have a great day, everyone.
Bye.
Thank you. Bye.